Dear students, in the last class, we have already discussed about operators defined on matrices. For today, you have to learn about properties of matrix addition. Number one property, commutative law. If A is a matrix of order m by n, B is a matrix of order m by n. A की matrix है m by n, B की matrix है m by n means A and the B are matrices of the same order, then A plus B is equal to B plus A. Addition of A plus B is same as addition of B plus A, and this property is known as commutative law. Number two, associative law. If A is a matrix of order m by n, B is a matrix of order m by n, C is a matrix of m by n, then addition of A plus B and C is equal to addition of A and the sum of B and C. Sigi property se koina apply to bayaragade. If A is a matrix of m by n, B is a matrix of m by n, C is a matrix of m by n, A, B, C se chap manaba order chap manaba matrix of matamda left hand side siga right hand side ka manaragade. This property is known as associative law. Number 3, existence of additive identity. Let A be a matrix of order m by n and O B and m by n zero matrix. Matrix A ama leraba magi order se m by n ni. Then there exists a matrix O matrix known as zero matrix of order m by n. Then A plus O is equal to O plus A is equal to matrix A. So O is the additive identity for the matrix addition. Haibadi matrix A ama laiba khudingi zero matrix ama exist tawgani. A duga zero ga plus tawba or zero ga A ga plus tawba sa A dum tani. Siki property se lairiba ngasai gi zero matrix to adugi maming kai kaurani additive identity for matrix addition kawe. Then number 4, the existence of the additive inverse. Let A be a matrix of m by n, then we have another matrix minus A, such that A plus minus A and minus A plus A is equal to 0. Now the matrix sum leraba minus A haibam exist tawgani A plus minus A or minus A plus A sina 0 dum taragadi. Minus A is the additive inverse of matrix A, or it is also known as negative of A hainiba. Any matrix A ready minus A haibam laini A duga minus A ga plus tawba or minus A ga plus tawba sa 0 matrix tagani. Duga sigi minus A si maming kay kaure additive inverse kawe. Duga mamangi existence of additive identity sina A haiba matrix ama laiba khudingi 0 matrix ama exist tawgani. A ga 0 ga plus tawba or 0 ga A ga plus tawba sa A masa se dum tagani. Next property, properties of multiplication of matrices. Number 1 property, the associative law. For any 3 matrices A, B, and C of suitable orders, we have multiplication of product of A, B, and C is same as multiplication of matrix A and product of B, C. Ko the A, B, C have a matrix ahum later. There are 3 matrices, matrix A, matrix B, and matrix C of the suitable orders. Suitable orders means product A, B should define to product B, C should define to and product of A, B ga C ga su define to or any product of A ga B, C ga su define to orders loina suitable oiba matrix ahum lauraba matamda sigi condition se akhona ya taragadi, that property is called associative property. Correct. Then number 2 property, distributive law. For any 3 matrices, matrix A, matrix B, and the matrix C, number 1, A into B plus C is equal to A into B plus A into C. Mana minter se kaino A into multiplication of matrix A and the sum of B plus C is same as sum of product of matrix A and the matrix B plus matrix A and matrix C. Habidi A ga into B plus C puthokpa matamda A into B hana puthosu yare, marakta plus sign thamani aduga A into C irasu yare. Number 2 the A plus B multiplied by C. Multiplication of A plus B and the matrix C is same as sum of product of matrix A and C and the matrix B into matrix C. Sige mawang the and this law is known as distributive law. Number 3, the existence of multiplicative identity. For every square matrix A, then there exists an identity matrix I of the same order such that I into A or A into I is equal to A. For any square matrix A, now on the square matrix A malaibu khudingi, there exists an identity matrix. Identity matrix is denoted by capital I such that I into A or A into I is same as matrix A, then I is called the multiplicative identity. Exercise 3.2. For question number 1, let A be a matrix of order 2 by 2, B is a matrix of order 2 by 2, and C is also a matrix of order 2 by 2. Square matrix natani man piris order su samanare. A, B, C are matrices, square matrices of the same order. Find each of the following for question number 1. Roman number 1, find A plus B. A ga B agi samputoni. Number 2, A minus B. Number 3, 3 times of A minus C. Number 4, A into B. Multiplication of matrix A and matrix B. And number 5, multiplication of matrix A and the matrix B. Question number 1. Question number 1 says solve the Question number 1. Let A, B, C matrix A to write all the given matrices, matrix A, matrix B, and matrix C. Roman number 1. Find A plus B. Write all the elements of matrix A and write the elements of matrix B. A gi matrix loine iro, B gi element loine ito A plus B. A plus B means addition of matrix A and matrix B. When the matrix addition, the matrix A ga B ga se kamaina plus the we hierarchy. A plus B is obtained by adding the corresponding elements of matrix A and the corresponding elements of matrix B. A ga B ga gi corresponding oinaba elements sing se plus tawgani. Aduna 2 siga kanaga plus tawgani. 2 plus 1. 2 plus 1 is equal to 3. And the 4 plus 3 is equal to 7. And the 3 plus minus 2. 3 plus minus 2 is plus 1. And 2 plus 5. 2 plus 5 is equal to 7. The matrix 3, 7, 1, 7 is the addition of matrix A and the matrix B. For Roman number 2, find A minus B. Subtract elements of matrix B from elements of matrix A. Matrix B ki element naam se matrix A dagi subtract tawro. Kamaina subtract tawrani. First write 2. Corresponding element is minus 1. Then write 4. Its corresponding element is 3. Write 3. Its corresponding element is minus 2. Minus minus, minus minus, plus. Then write plus 2. Its corresponding element is plus 5. We have to write minus 5. And find the difference of these numbers. 2 minus 1. 2 minus 1 is equal to plus 1. 4 minus 3. 4 minus 3 is plus 1. 3 plus 2. The sum of 3 and 2 is 5, and 2 minus 5. The difference of 2 and minus 5 is equal to minus 3. This is the difference of matrix A and the matrix B. For Roman number 3, we have to find the expression 3 times of A minus C. 3 is a scalar multiple of matrix A. Write all the elements of matrix A. Matrix A gi elements 2, 4, 3, 2 ne, sian ito ne. Then write C. C marakta minus am laire aduga C gi element ito. Elements of the matrix C are first row minus 2, 5, second row 3, 4. C ito 3 times of A. Scalar multiplication of the matrix A by the scalar 3, which is obtained by multiplying its element of the matrix A by the scalar 3. So we have to multiply matrix A by 3. 3 into 2, 6. 3 into 4, 12. And 3, 3, 9. 3, 2, 6. 3 times of A puto A. Then write all the elements of matrix C. Matrix C gi element ito si. Matrix C gi element ito. Then marakta kai sign later. There is a minus sign in between first matrix and the second matrix. So we have to subtract elements of the second matrix from the elements of the first matrix. Corresponding elements are 6. Minus minus, it will be plus. Then write 12. Its corresponding element is 5. We have to write minus 5. Plus 9. Corresponding element is minus 3. Write 6. Its corresponding element is minus 4. So find the difference of these numbers. 6 plus 2. 6 plus 2 is 8. 12 minus 5. 12 minus 5 is equal to plus 7. 9 minus 3. 9 minus 3 is equal to 6. And 6 minus 4 is equal to 2. This matrix is the value of the expression 3 times of A minus C. Nangon the period given expression C gi value sa C tarani. Then number 4. Number 4 the kaidorani. Multiplication of matrices. We have to multiply this matrix A by matrix B. Matrix A is the matrix B na multiply tawani. Adidi koina first set matrix A and the matrix B are compatible for multiplication. Matrix and is a multiplication tawba yabra haina check tawgani mamangi last class taina takre. Right the orders of matrix A. Order of matrix A is 2 by 2, and also write the order of the matrix B. Matrix A ki order is 2 by 2 ni. Matrix B ki order is 2 by 2 ni. Then check the number of columns of the first matrix is equal to the number of rows of the second matrix. In this case, the number of columns of the first matrix is equal to the number of rows of the second matrix. So A and the B are compatible for multiplication. Multiplication puthokpa yaba matrix oire aduna koina A B se define the where. Then how to find the product of matrix A and the matrix B? Rule apply to elements of first row and the second row of the matrix A should be multiplied by elements of first column and second column of the matrix B. Have the first row first row second row matrix kanagi A gi aduga B gina first column second column magi corresponding elements sing multiply tawgadabani. Then 1 minus 2 jani rasi 1 and minus 2. 1 minus 2 na multiply to was an itosi kay tarani 1 into 1. Find the sum of product of corresponding elements. 1 into 2 is equal to 2. Minus 2 into 4 is equal to minus 8. Then 1 into 3 is 3. And minus 2 into plus 2 is equal to minus 4. Kuna first row, second row sida first column na multiply to bolore, then second element 3 and 5. Elements of first row and the second row multiply by 3 5. 3 5 sina multiply to run. Next, write elements of second column 3 5 is the elements of the row 3 5 and 8 all. Find the sum of product of corresponding element. Corresponding element ki product putosi ko 3 ga 2 ga 3 into 2 is plus 5 into 4 is equal to 20, and the 3 3 9 plus and 5 2 is equal to 10. Find the sum of these numbers. 2 minus 8. 2 minus 8 is equal to minus 6. 6 plus 20 is 26, and 3 minus 4 is equal to minus 1. 9 plus 10 is equal to 19. So my taraga ko na multiplication of A and B sa putok parent. Then last question, Roman number 5. B into A. B into A se kamay putok ni B orderan ito. First write the orders of B. Order of B is 2 by 2, and write the order of matrix A 2 by 2 iro. Number of columns of the first matrix is equal to number of rows of the second matrix. Ani se manaragadi B A se akoina multiplication putok pare. We can define the multiplication of B into A. Then multiplication putosi. Multiplication putok matamda first row and second row multiply by the elements of the first column and elements of the second column. So write the elements of first column is the elements of first row. Row gimong the ito 2 into 1 is equal to 2 plus 3 3 is equal to 9. 2 into minus 2 is equal to minus 4, and the 3 5 is equal to 15. So my taraga first row na multiply to sin basilore. Then elements of the second column 0. Elements of the second column say 4 2 ne. See the 4 2 ito say yuga product. Find the sum of product of corresponding elements. 4 into 1 is 4 plus 2 into 3 is 6. 4 into minus 2 minus 8 plus 2 into 5 is equal to plus 10. So find the sum of these numbers. 9 plus 2 11. 6 plus 4 10. Minus 4 plus 15 is equal to 11. Minus 8 plus 2 is equal to plus 2.